Hi everyone, it's Mrs. Griffin with the Unit 8 Lesson 8 video about segments that are in secants and tangents of a circle. So pause this and try the opening exercise. And here are my answers. So for the first one, we needed to create two different equations because opposite angles in a quadrilateral are supplements. And then when I clean them up and set them up here, I have a system. And so when you solve that system of equations, A is 25 and B is 20. And for 2, you're either using Pythag or special right triangles to get G is 4 radical 2. So going on to our notes. We have proven the theorems that we're going to use in these notes already in the previous 2 lessons. So for starters, we're going to talk about what happens when we have two tangents that meet one another. So if a tangent, remember, only touches a circle in one spot. So if we have a tangent here and a tangent here, and they happen to intersect, those two tangents have a special property. So between the point of intersection and the point of tangency on one, and the point of intersection and the point of tangency on the other, they end up congruent. We proved this back in lesson 7 when we did number 4, because we were able to show that when we had these two tangents, A and B were equal at CPCTC. So anytime we had tangents from the same point, those are going to be congruent to one another. The second two properties are what happens when we deal with secants, or secants and tangents in the same circle. So if we have two secants, or if we have one of each, a secant and a tangent, there's a slightly different rule, and we proved that back in lesson 6 when we did number 2. So in number 2, you can see that we had proven that RQ was congruent to RP, times RP was equal to RS times RT. And if you look at what they're discussing in those, RQ is the outside portion of the top secant, and it's getting multiplied by RP, which is the entire length of that top secant. And then on the other side of the equal sign, it's RS, which is the outside part, times the entire whole segment that it's part of. Using that idea, we are going to summarize our formula. Now, I like to use the words outside portion times whole from one tangent, or from one secant, equals the outside portion times the whole of the second one. So when we look at this, we have the outside portion here, and then the whole thing here, which if you only had the two pieces, you would have to add them. Otherwise, if you had the length already, you could use it that way. And on the bottom tangent, or secant, you have the outside portion is C, and then the entire thing from there to there would be C plus D. And sometimes it's already added for you. They give it to you as the whole, so that's fine. You can use it that way. All right, and then the same thing here. We have our outside portion times our whole. And then if you look at this piece, there's only C. There's not another secondary portion because the whole part of the tangent is outside. So using this idea of outside and whole, the outside part is C, and the whole thing is also C. So when you have the tangent, you're just going to have it as squared. Okay? But it's this rule for both of them. So now applying that rule, or those rules, we're going to have some examples. So in number 1, if you look at circle C, we have two tangents that both come to it. You can tell they're tangents because they only can have one point of intersection, so that makes these segments congruent. And then when you look at circle C prime, these segments are both tangents to that one. And so these would be congruent, and therefore all 3 segments here, here, and here would have to be congruent. So I could set these equal. So 6x plus 5 would have to equal 37 minus 2x, and then I could solve. Add 2x to both sides, subtract 5, and then divide by 8. All right, number 2. Now what we have here are two secants. So we're going to use the outside times whole idea. The outside portion of this secant is 3. And then the entire secant, if I were to put those together, is x plus 3. So I'm going to write 3 times x plus 3. And then on the bottom one, the outside part's the 2. And then the entire thing we'd be taking that 10 and 2, adding them together. So the outside part is the 2, and then 10 plus 2 is 12 to get the whole thing. Alright, so outside times whole, outside times whole. And then we can distribute and solve. So 3x plus 9 equals 24. Subtract 9 from both sides. And then divide by 3, and you get 5. Right. Same concept on 3, only this time this is a tangent. So x is the outside portion, and it is the whole portion. So you can write it as x squared. For the bottom secant, we have the outside portion is 9, and then the whole thing is 9 and 7, which is 16. So outside times whole equals outside times whole. And 9 times 16 is 144. And when you square root both sides, you'll get positive or negative 12, but we only keep the positive 12. Okay, for number 4, these are both tangents, so we are going to set them equal to one another. And this one, if you can see, has x squared and a regular x. This is going to end up quadratic. So in order to solve a quadratic equation, we need to get it equal to 0. So 2x squared plus 3x minus 5 equals 0. With a coefficient in front, remember you have to multiply these together. And so we are looking for numbers that multiply to negative 10 and add to a positive 3. And so that would be a negative 2 times a positive 5. And then with the number in front, we have to break apart that center term. So we have 4 pieces, and then we're GCF for each piece. So we'll take out a 2x from the first 2 and be left with x minus 1. We'll take out a 5 from the second 2, a positive 5 because we always keep the front term. And when we divide that out, we'll also have x minus 1. And then we'll take the x minus 1 out, leaving us with the second factor of 2x plus 5. And then we're going to solve each piece. So x minus 1 equals 0 gets us a positive 1, and 2x plus 5 equals 0 ends up with a negative 2.5. Okay, now when I substitute those x's back into check, substituting in a 1 would get me a positive number, so that one's okay. But substituting in a negative 2.5 up here is going to end up with a negative answer, so this one gets rejected. Okay, on to number 5. So now you can see we're outside times whole because we don't have 2 tangents. So the outside portion is 21. The entire thing, if I add that together, is 2x plus 29. So outside times whole. Okay, and on the other side, the outside portion is the 27. And the whole thing is when you put the 27 and the x together. All right, now to solve this, we'll distribute. So 21 times 2x is 42x. 21 times 29 is 609. 27 times 27 plus x gets you 729 plus 27x when you distribute. And now we're going to solve. So I'll subtract 27x from both sides, and I'll subtract the 609 from both sides, and then I'll divide by 15. I'll get 8. All right, going on to number 6. We're looking for PQ, so I'm going to call that x. And then again, it's outside times whole equals outside times whole. So the outside portion here is the 24, and the whole thing is the x plus the 24. And then on the bottom, the outside portion is 36. The whole thing is also 36 because it's a tangent. So we're doing 36 times 36, or 36 squared. And then we can distribute. 24x plus 576 equals 1296. And subtract your 576 from both sides. And then divide by 24 and you get 30. All right, for number 7, again, outside times whole equals outside times whole. For this portion, it is a tangent, so the outside is the whole. So you can do 3x times 3x, which is the same as doing 3x squared, either way. And then for the bottom half, 2x is outside, and the whole thing is 2x plus 10. Okay, so we're going to distribute. 3x squared, when you square 3x, you get 9x squared. And when you distribute here, you get 4x squared plus 20x. And then we're going to subtract and make it all equal 0 because we do have x squareds and x's. So we're going to subtract the 4x over and the 20x over. And now it's GCF. So we're taking a GCF of 5x out. Both are divisible by 5x, leaving us x minus 4. And then we're separating. 5x equals 0, x minus 4 equals 0, and we're solving. Divide by 5 on both sides here, and you'll get 0. And add 4 to both sides here, and you'll get 4. Check them. Plugging in a 0 here is going to get me a length of 0, which is not acceptable. You can't have a length that's 0. So 3 times 4 would be 12, and 2 times 4 would be 8. This one does work out to be logical numbers for our circle. And then finally, numbers 8 and 9. Same process. We're doing our outside times whole equals outside times whole. For number 8, it's a tangent, so the outside and the whole are the same thing. So x times x, or x squared. And for the bottom portion, the outside is x minus 2. You got to put that together. And then the whole thing is 2x minus 3. So we are going to have to distribute this. So 2x squared minus 3x minus 4x plus 6. And since it's quadratic again, I have x squareds and just x's. I'm going to make it equal to 0 again, but I really want to have a positive x squared term. So I'm going to subtract this way so that I have a positive x squared term. And now this is a normal trinomial, so we are just looking for numbers that add to -7 and multiply to 6, positive 6. So I would use a -1 and a -6 and solve each one. So x minus 1 would equal 0 and x minus 6 would equal 0. And I'm going to get a 1 and a 6. And again, I need to check both of those answers to see what makes sense and doesn't give me something weird. So if I plugged a 1 in here, I'd end up with a length of -1 on that outside segment. That's not allowed, so that's not going to work. If I plugged a 6 in, though, 6 minus 4 is, or 2 is 4, and 6 minus 1 is 5. So I get positive numbers for both of those, and that's okay. And then finally, number 9, same idea. Outside times whole equals outside times whole. The outside portion here is x plus 2. Since it's a binomial, it goes in parentheses. And the whole thing, if you add those together, is going to be 3x minus 6. Okay, and then on the bottom part, x plus 1 is the outside portion. And the whole thing, if you add those together, is 3x minus 4. And then we're going to distribute on both sides. So 3x squared minus 6x plus 6x minus 12. And 3x squared minus 4x plus 3x minus 4. Simplify everything down. These cancel. And try to solve. Now notice on this particular one, even though I have x squareds and x's, if I try to get the x squareds together, they disappear, so they cancel away. So this is not actually a quadratic equation. So I'm going to add the 4 to both sides, and then divide by -1. And I'll get positive 8. All right. So major rule here is outside times whole equals outside times whole. Make sure you memorize it. I'll see you in class.